Business math, right? Can you hear me in South Boston? You're muted right now. Can you unmute yourself?
Can you hear me now?
Yes, ma'am. Thank you.
Okay.
Business math, right?
Yes, sir.
Okay. We're going to go through the first module practice quiz. I don't know if you tried it at all, but we'll go ahead and work all the problems out.
Okay.
So let's see here. It's percents and decimals, which is a lot of times a review, but it may have been a while since you did this. So it's a good review to have. Let's see. Here's our Canvas course, and here's our module. And there's some videos, just probably Khan Academy type videos there. And then the practice quiz, I don't know if you tried it, but you can take this practice quiz as many times as you want because it's just practice. And then the test is available. We'll probably set a due date today just to kind of keep people going. And 1 second here.
Mr. Ritchie,
Yes.
can you tell me your meeting ID number so I can know it?
You want to zoom in on that computer?
Yeah, I was going to like for future purposes.
Yeah, it's easier on the computer. The way to do it on your computer is to go to the Canvas class. And when you get in the Canvas class, you'll see where it says Zoom links in the begin here, right on the home page. When you click on Zoom links, it has the link to join the class that way.
Okay.
So I'll give you a minute to do that.
I tried it, but it acted like I had to get your ID.
Yeah, if you just open sometimes if you just open that Zoom thing on a computer, it wants class ID, which I can probably give you that too. If that link doesn't work, I'll give you the ID. Let me try that. Let's see. I'll share my screen. Here's there's the meeting ID if you need it right there. If you want to try that. If you can see that on the screen.
Okay, I got it. Thanks.
All right, good. All right, let's see. Where am I? Back to the class. And practice quiz. Here we go. So we'll go through and actually take this. There'll be some calculator work here. None of it's terribly difficult though. All right. Do you remember, or do we remember converting percents to decimals? And then of course we go the other way sometimes too, where we convert decimals to percents. So sometimes we go percents and we change it to a decimal. And sometimes we take decimals, and we make those percents. And it's really just about moving the decimal place. If I'm given something like 8.4%, I move and I want to change it to a decimal. I move my decimal 2 spots to the left. If there's no number here, I fill in with zeros. So that would become 0.084 as a decimal, starting from a percent. So this question, it's got 0.52%. So we have to go to the left to make it a decimal. So 0.52%, the decimal goes 2 spots to the left. There are no digits there, so we fill in with zeros and we get 0.0052. And of course, if we want to go decimals to percents, we go the other way. If we have 0.64, we would go 2.2 to the right to get 64%. So one way you move the decimal to the left, the other way you move the decimal to the right. On this particular question, decimal to the left, because we're going from percent to decimal. So that's right there. Boom. All right, convert this to a percent. If we're converting to a percent, which way do we move the decimal place?
Right.
To the right. So there's no zero here, or there's no digit here, so we fill in. 5.5 becomes 550%. Here we go again. Convert 8.6 to a percent. Excuse me. 8.6 to a percent. We go 2 to the right. 1, 2. Add our 0. 860%. Now I know it looks strange sometimes to be over 100%, but it certainly can happen. So don't let it make you think you got it wrong. 860% is correct. And just stop me along the way if you have any questions. All right, now these questions that deal with either decimals or percents have to do with this formula. It's usually written this way: P equals B times R, where P, some books call that the part, some books call it the portion. The B is the base. And the R is the rate. The rate's usually easy to identify because it's usually in a percent. You know, if you have a class of 30 students and you want to know what's 10% of 30, then 30 is your base. So you multiply 10% times 30, and that gives you 3, and that's your part or your portion. Now, of course, this formula could be written 3 different ways. If you're looking for your part, you take your base times your rate. If you're looking for the base, you take the part and divide it by the rate. And if you're looking for your rate, you take your part and divide it by the base.
Can you slide a Zoom video? I can't do it first.
What's that?
Can you slide the Zoom video? I can't really see the equation on the side.
You can't see it?
Yeah, the first one is P equals B times R, right?
Yeah. Is it off the screen or where?
Yeah, it's the Zoom of the different classes at the bottom of the screen.
I don't have anything else on my screen. That must be locally on your screen.
Yeah.
So I'm not sure. I can't control.
Oh, that's okay. I was just making sure that's what it's saying.
Yeah. It says P equals B times R. Then it says B equals P over R and R equals P over B. I'll try to write higher up on the screen.
Okay, I got it now. Thank you.
Okay. I'll write it up here. P equals the base times the rate. The base equals the part divided by the rate. And finally, the rate equals the part divided by the base. So really what becomes the challenge is choosing or figuring out what you're given, whether you're given the part, the rate, or the base, and what it is you're looking for. The base typically comes after the word of. If it says 30% of 3,000, then that 3,000 is usually your base. You know, what is 25% of 8,000? 8,000, because it comes after the word of, is your base. That's a good way to do it. So in this problem, 6,100 computer chips, if 2.5% were defective, how many were not defective? Well, first of all, let's find the defective ones, and then we'll know how many was not defective. 2.5% of 6,100 were defective. So I'm going to use that formula, the very first formula up here. I'll number them so you can see which ones I'm referring to. And I'll say, okay, I got 6,100 computer chips, 2.5%. Now let me convert that to a decimal so it can go in a calculator easy. 2.5 percent. So there's a decimal. That becomes 0.025. So 6,100 times 0.025 will give me the defective ones. Do you have a calculator there? Well, I got a calculator here too. Let me figure that out. 6,100 times 0.025. There we go. 6,100 times 0.025, 152.5. So if 152.5 were the defective ones, the question asked, be careful, how many is not defective? So I'll take 6,100 and I'll subtract 152.5 And then it says round my answer back up to the whole number, but let me subtract first. I get 5947.5. Rounding that up to a whole number, 5948. All right, what is 29.5% of 910? Which formula am I going to use? What am I looking for?
Um,
Well, I guess I could label what I have. What's the 29.5%? Base rate or part?
is that the part?
Well,
No,
go ahead.
is that the rate?
That's very good. Yeah, the percent usually tell us that that's the rate. Now, what's the 910?
Is that the base?
That's the base because we're talking about taking 29.5% of 910. So I'm looking for the part. So I'm going to use that first one. Part equals base times rate. I take 29.5%, change it to a decimal. I get 0.295. So to find my answer, I take 910 times 0.295. And what do I get?
$268.45.
Very good. Right there. Boom. Similar problem. What is 71.5% of 600? So I'm looking for the part again. 71.5% as a decimal, 0.715 times, and I keep switching notation here, but do it however you like to do it, parentheses or the multiplication sign. So take 0.715 times 600 and tell me what you get.
$449.
There you go. Very good. Electron Tube Electronics made 50,000 TVs last month. If 3.5% were high definition, how many high definition were there? So we want to know what 3.5% of 50,000 is. So that sounds to me like this is the base and this is the rate. So we're looking for the part. 3.5% as a decimal. Boom, boom. 0.035. So we do 50,000 times 0.035. And that's what, 1750?
Yeah.
All right, good. All right, next. Orlando has finished pouring 4,865 cubic feet out of a total of 27,000 cubic feet of concrete. What percent of the job has he completed? So it asked me what percent. So that means this. I'm looking for the rate. The whole, the base is the 27,000. The part of that is the 4,865. So my rate will be equal to the part divided by the base. Which is 4,865 divided by 27,000.
I got 0.18.
Right? 0.1802.
Yeah.
Now that's, of course, as a decimal. The answers are all percents. So we'll convert that by moving the decimal place two places to the right. Get 18.02%. Very good. All right, we're looking for the rate again. Statistics show the sales force of Golden Wholesaler closed 1,711 sales out of 1950. What was the percent success rate? The whole was the total sales calls. So this is the base. And the part would be the successful ones. So that's the part. So the rate equals 1711 divided by 1950.
Zero point 877.
0.877. So as a percent, we move our decimal and we get 87.7%. Right there.
Are we still using the rate formula?
Let's see here. Yeah, it looks like we're using the rate formula, doesn't it? And which one is the part and which one is the base?
The part is 362.
Very good. And this is the base.
Zero point 2413.
And they want us to, let's see, so if we convert that to a percent like that, we get 24.13%, but it tells us to round to the nearest whole percent. So 24. All right, let's see. Next. All right, now it says 167.48 is 53% of what number? So the 53%, that's the rate. Now, notice here's that word of what number? So the what number, that's the base because that comes after the of. So we're looking for the base. So that means this 167 must be the part. So base equals part over rate. So base equals 167.48. We convert 53% to a decimal. We get 0.53. So we need to divide 167.48 by 0.53.
$3.16.
Very good. This test is going to take you less than 30 minutes, I bet. Okay. They do get more challenging though. All right, 75.5% of the students at Sarasota Community College are from in-state. If 24,950 students are from in-state, how many students total attend the college? So this is the rate. These are just the in-state students, and they want to know how many students total. So this must be the part, because that's just part of the students, right? The ones that are in-state. So we are looking for, this is the rate. I wrote a P over here. There it is, rate. I'm looking for the base. So the base is that's the second formula up there. The part divided by the rate, written as a decimal, 0.755.
I got 33,046.35.
Okay, and it says round to the nearest whole number, so we'll just call it 33,046. So the total number of students that go to Sarasota Community College are 33,046. (82.25%). I know what that is already. That's my rate. Of the employees at industrial mechanics are college graduates. If 254 employees are college graduates, what's the total number of people employed? So this sounds like the part here, because those are just the college graduates, and I'm looking for everybody. So base equals 254, the part, divided by the rate, written as a decimal, 0.8225. And then we'll round it to a whole number.
$309.
All right. Very good. There we go. All right, last month, Quick Industries produced 900 units. This month, they produced 1,264. What is the rate of change in production? Well, before we can find, we're looking for the rate, obviously, because they say, what is the rate of change? I need to find what the increase was. How do I find the increase? If you had a business and you sold 9,000 or made 900 units one month, and then 1,264 the next month, how many more did you make?
You subtracted from the 900, right?
Yeah, very good. So you take 1,264, subtract the 900, and that gives us go ahead, 364. Now we want to know what the rate is. So we're looking for the rate and change. We started with 900 units. So that's going to be our base. And we divide that into, this is our part. So our rate of increase is based on our beginning amount as the base, 900. And we divide it into the part, 364.
That's 0.404.
All right, and then as a percent, that is 40.4%.
It's pretty easy.
Yeah, these aren't bad. This first section, we only really need to spend one class on this module. Some of the future, I think most other modules we'll probably spend 2 classes on because the formulas are a little more involved. But it's good that you're finding it easy because it's not easy for everybody. So that's good. 17% of a city's population use Wi-Fi. If 20,508 people use Wi-Fi, how many people live in the city? Well, here's our rate. What is that 20,000 number?
Base.
Well, those are just the people that use Wi-Fi.
Oh.
And they want to say how many total people live in the city. So what would that, that's what then? What's the 20? Right, because that's just the part of the whole city that uses Wi-Fi. Does that make sense?
Yeah, at first I got confused because I thought we was saying how many people use the Wi-Fi. It's talking about how many.
Yeah, that's the 20,000 is only the Wi-Fi users, but they want to know how many total people live in the city. So the total people will include the people that use the Wi-Fi and the people who don't use the Wi-Fi. So that's what we're looking for, is the base. So we put the part, we use that formula number 2 up there, and we take the part and divide it by the rate written as a decimal, 0.17.
$120,635.
Perfect. Well, round up the whole number, so 126.35. Very good. If a number increases from 900 to 1107, what's the rate of change? We did one similar to this. How did we find that increase? If we went from 900 to 1107, how much did we increase?
subtract, right?
Very good. Start with that 1107, subtract the 900. That'll tell us our increase, which will become our part. And that is 207.
Yeah.
Now, just remember when you're the rate of change, you're always, the base is going to be the beginning number. Because you're wondering what percent did I change from the 900? So don't accidentally divide by the 1107. You divide by that first beginning number. So the rate of change will be the change amount, the part 207 divided by the base 900.
Point 23.
0.23, which is 23%. Nice. One more. Now the test has got might have a few more questions on it, but they should all be very similar questions. And if you have any questions while you're working through the test, you can always, well, the tests aren't timed for one thing, so you can always stop and come back.
Okay.
But you can also text me at this number and I will help you.
Okay, great.
So if you do that, text me at this number. I try to get back to you fairly quickly. Tell me which number the question is that you're trying to do. And if we can't answer it by text, we can do a phone call, or I can do an individual Zoom, or we'll work it out.
Okay.
All right, so let's see. Ezekiel manages a clothing store. In May, the sales were 129,800. In June, they were 131,975. What's the rate of change? Very similar to what we were doing. You find the increase, which you told me last time was to take the June amount, subtract the May amount from it, so we can see how many we increased. Oops.
2,175.
What was it? What did this come out to?
2,175.
Thank you. All right, so that becomes our part. And we divide it by that beginning sales number because we want to know what percent we went up from that. So 2175 divided by 129,800.
Is that 0.016.
0.016 what?
1675.
All right. Now, to go to a percent, we come over two spots here. So this becomes 1.675%. And it looks like all my answers are to one decimal place. So I want to round up to here. So that's going to be 1.7%, right? 1.67 rounds up to 1.7%. All right, and that is that. All right, now I'm going to put a due date in here for Sunday night for the test at midnight. If you need to go later than that, just let me know. It's no big deal. You can do that, but I'm going to put a due date because if I don't put a due date in, it won't show up on your calendar. When I put due dates in Canvas, then it shows up when you look at your things to do list or whatever it is on Canvas that the students use. When I put due dates on there, it'll show up. So it just helps remind the students to do it. It's not written in concrete. So if you need to take some more time, that's certainly fine. But I just like to get a due date in there. So I'm going to insert that due date in. But that'll do it for today.
Okay.
And next, and just let me know if you need any help. Just shoot me a text.
Okay, I will.
All right. Well, have a good week.
Thank you. You too.
All right. Bye.
Bye.